Superconductivity. So, suppose there is a material uh, at room temperature and it is having a resistance which is greater than zero, constant resistance. Okay, the same material, I am putting it below a certain temperature, and this certain temperature is called the critical temperature. So I am putting it below this particular temperature. And what happens is that when I put it below that particular temperature, then its resistivity becomes zero. That is, it will enter the superconducting stage. So imagine like this is a material, this is a conductor, and this is at room temperature, and its resistance is a constant number. Now I'm putting it in a big freezer where I can adjust temperatures to whatever amount I can. So I'm putting it in such a refrigerator, and below a particular temperature, when I reduce the temperature below a particular temperature, this material's resistance becomes zero. Resistance means zero. Resistance becomes zero means the material has entered the stage of superconductivity. So, this is the phenomenon called superconductivity. I hope you got it. Then, it was first discovered in 1911 by H.K. Onnes. He's a scientist, and it was for mercury he found it. That is, at he found like minus 269 degrees Celsius, or which is equal to 4 Kelvin. So, if he is putting mercury below a temperature of 4 Kelvin, it is entering this superconductivity stage. That is, its resistance is becoming zero. So, the material is put below a certain temperature. That certain temperature is called the critical temperature. So, whenever materials are put below this temperature, they exhibit superconductivity, and this temperature will be different for different materials. So, for superconductivity, then there are two basic properties. First is, we told, resistance is zero, and current can circulate inside the material without any dissipation of energy. The resistance is equal to zero means that current will be circulating inside the material without any dissipation of energy. Okay, and the second thing is like this. So suppose the material is at room temperature, then the magnetic field lines will be like this. It will be passing through the conducting material. Let it be a conductor or a semiconductor. What happens is like the magnetic field will be passing through it. So once we put the material below the critical temperature, then what happens is like the magnetic field, it is bent around the device so that no magnetic field lines will be going through the inside. It will all be going like this. It will take a bending path, see, like a bending path. And this phenomenon is called Meissner effect. That is, when a material is put below the critical temperature, the magnetic field lines will bend around it. So this is what is Meissner effect. And effect is mainly applicable in maglev trains and all. You can see like a magnet is able to levitate above a superconductor due to this Meissner effect. You can imagine, you can see the effects of like how a magnetic train works, this maglev trains and all. So this is a basic principle, Meissner effect. Then TC, which I have already told you, is different for different material. That is critical temperature. That temperature below the critical temperature is like the boundary or the border. So suppose this is a critical temperature. So what happens is like, if the object is heated, means like if object is here, this is the critical temperature, it is the boundary. So after this it will be behaving normal, like a normal conductor or semiconductor. But below this below this, it will be like a conductor, or it will be a superconductor. So that is the difference. And then there is something called high temperature superconductors. So that these superconductors, I mean, like there are certain materials such as barium, copper, etc. So they don't have to be cooled, they don't have to be put in a very low temperature. Like I told you, like for mercury it was 4 Kelvin. So but for these metals, no, around 90K, if they are put under 90K, they will exhibit superconductivity. So they don't need a very low temperature. So these are called high temperature superconductors. So it's very useful, as we don't have to go to the extreme level of cooling and all, and so it is easy to achieve superconductivity for this materials. Now, the superconductivity state can be destroyed by a rise in temperature or in the applied magnetic field, which then penetrates the material and suppresses the Meissner effect. That is simple, which I told. As the temperature is increased very high, the superconductivity will get destroyed. I mean, like, see, we are cooling a material, we are putting a material below a certain temperature, like this below on the left side, it will be a superconductor, and if this crosses the temperature, crosses this thing, it will be a conductor or a semiconductor, that normal what the thing is. So, or else if you increase the magnetic field, the strength of the magnetic field, then also it will destroy the superconductivity. Just like we saw, below this critical temperature, what happens is the magnetic field lines will below, if it is below this temperature, the magnetic field lines, it will become a superconductor, and the magnetic field lines will be bending around it. That is Meissner effect. But if we increase the magnetic field, we are applying strong magnetic field, then what happens is, like those which is bended around this, it will try to enter in the material, and after so much intensity, in so much intensity we are giving the magnetic field, so it will obviously enter the material, and the material will eventually lose superconductivity. So based on this, there is a classification called type 1 superconductors, and so based on this based on this, which we discussed, the classification is like type 1 superconductor and type 2 superconductor. So for type 1 superconductors, what happens is, we have to apply a very small magnetic field, then it will lose its superconductivity. But for type 2, we have to apply very, very, very strong magnetic fields, then only it will lose superconductivity. So, in the case of type 1, where if we apply a very small magnetic or a very weak or a very small magnetic field, so this is a graph. See, if the magnetic field we are increasing, and once when it reaches a particular stage, it will become normal. From semiconductor stage 2, it will become a normal. But in the case of type 2, if you see, you can find like, so the semiconductor stage, no, we are applying the magnetic field. Once it reaches a particular point, it will enter a mixed state. Mixed state is like, the magnetic flux lines, which I have told, like in Meissner effect, it will be bending around it, right? It won't go through the material, it will be bending around the material. So in this mixed state, some of the magnetic flux lines will be able to go through the material. So again we are applying higher and higher, so we are applying a very high magnetic field, and what happens, it will enter the normal state. Normal state means all the magnetic flux lines will be passing through it. So that is it. And type 1 generally, it obeys Meissner effect perfectly, and this only because of this mixed state, it partially only obeys Meissner effect. And this type 1 is also called soft superconductors, and type 2 is hard superconductors. And type 1, the type 1 type 1, the property of type 1 superconductivity can be explained by a theory called the BCS theory. And this particular theory, BCS theory is a very important theory, which is explaining how superconductivity is occurring in material at the quantum level. So that is explanation. I think we don't have to go into that much detail, but further you should understand, like there is a theory called BCS theory, which can explain type 1 superconductivity, but not type 2. Type 2 can't be explained by the BCS theory. And this BCS theory, there are three American researchers, John Bardeen, Leon Cooper, and John Schrieffer. So in 1957, they established this theory. It is called the microscopic theory of superconductors. It is called like quantum level. you will be able to know how these things occur. I mean, like how superconductivity occurs. Like, it's like what happens is like there will be electrons, they group into pairs, and these pairs are called Cooper pairs. And they group in how they group into pairs is like through interaction with the various, you know with the vibrations of the lattice, it's so called phonons. Then they move around inside the solid with friction, and like that story is. So I don't think you don't have to go that much deeper into it. You just understand like BCS theory is a theory which is explaining the microscopic theory of superconductivity. And only type 1 superconductors can be, the reason for superconductivity can be explained by this PCS theory, but for type 2 it is not applicable. So that is all regarding superconductivity. I think you know what is superconductivity, and why superconductivity occurs. And not sorry Yeah, Meissner effect, then different how the superconductivity can be destroyed, and based on that type 1 and type 2 superconductors, and finally the BCS theory. So this is all to have a basic idea about what superconductivity is. This is I try to make it the very easy way to understand. I hope it's really helpful for all of you. Thank you.